Okay, so Amazon is building another phone, and I can hear you already. I know, the Fire phone was a disaster. But honestly, this time feels completely different.
Oh man.
I know, right? But hear me out, because the premise has completely changed.
The Fire phone was 2014, a £170 million write-down, 14 months on the market before they pulled it.
Right, but that phone tried to win with gimmicks. Remember the 3D display? The 4 front-facing cameras? Nobody wanted that.
Solution looking for a problem.
Exactly, but this new one, codenamed Transformer, it's AI native from the ground up, synced to Alexa, and here's the bit that really matters. It might bypass app stores entirely.
No App Store, no Google Play, no 30% cut going to Apple or Google.
Think about that for a second. That's not a phone, that's a platform play.
Okay, but who's actually going to use this? Like, a real person?
Well, that's the question, isn't it? But here's what stood out to me. They hired Jay Allard to lead the project, former Microsoft executive who designed the Xbox. That hire alone tells you how seriously they're taking this.
And they haven't approached wireless carriers yet, which raises a proper question. What is this device?
Right? Because Amazon has 2 separate satellite projects running right now. Project Kuiper, their broadband network with over 7,000 satellites approved by the FCC, and Sidewalk, their mesh networking protocol that uses Echo and Ring devices.
So they're building the network too.
Exactly. A phone without carrier dependence suddenly doesn't look like a gamble. It looks like the next logical step in infrastructure they already own.
They're reportedly exploring 2 versions, a conventional smartphone and a stripped-down dumb phone with minimal features. They're hedging their bets on what AI-first mobile actually means.
So the takeaway here, Amazon isn't just building a phone, they're building the network, the assistant, the delivery system, and now the device itself. Vertical integration at a scale nobody else can match.
Worth thinking about for anyone building on someone else's platform, right? Because this is what it looks like when the platform owner decides to compete.
Yeah, exactly. Okay, so completely different corner of the tech world now. Blue Origin just asked the FCC for permission to launch 51,600 satellites.
The project is called Sunrise, and these aren't broadband satellites.
Right, these are orbital data centers. Let that sink in for a second.
Wait, data centers in space?
Jeff Bezos' space venture wants to move compute infrastructure into orbit, and the logic is actually pretty straightforward. Earth-bound data centers have 2 massive constraints: power and cooling.
AI models generate enormous heat. Keeping them running requires industrial-scale cooling systems that use staggering amounts of water and electricity. In space, unlimited solar power, and the void of space handles cooling for free.
These satellites would use laser links to communicate with each other and with TerraWave, Blue Origin's other constellation for broadband. So you'd have a mesh of compute nodes in orbit, processing AI workloads without the physical constraints of ground-based infrastructure.
Okay, but who's paying for it? Launching 50,000 satellites isn't cheap.
Even with reusable rockets bringing costs down, this is a decade-long infrastructure bet that requires customers willing to pay premium prices for orbital compute.
But here's what stood out to me. Blue Origin isn't the only one doing this. SpaceX has similar ambitions, and the fact that 2 of the world's biggest space companies are placing the same bet, that tells you something about where they think the bottleneck is.
The barrier to better AI might not be smarter algorithms, it might just be heat and power.
Yeah, and if that's the case, moving compute into space starts to look less like science fiction and more like inevitable infrastructure. Honestly, I keep coming back to this one, because it's so big picture.
It's a decade away from being practical, but the fact that they're filing now means the planning is already underway.
Right, okay, so this next one is a bit darker. A reporter tried DoorDash's new app called Tasks, and what they found was honestly pretty bleak.
Oh, I read this one. Not good.
The app pays gig workers to train AI models, but not by labeling images or transcribing audio, by recording themselves performing everyday activities, doing laundry, cooking, folding clothes, walking upstairs.
The pay is low, really low, a few dollars per task.
And the tasks themselves are mundane to the point of absurdity. But the economic model is what matters here. This is what AI training looks like at scale. Not PhDs in research labs, not expert annotators, just people who need extra money, recording the ordinary things humans do, so machines can learn to do them.
Workers training their own replacements and getting paid just enough to keep doing it.
Yeah, that's not a future scenario. That's happening right now. Full disclosure, I've been thinking about this all morning because the optimistic version of AI is that it frees humans from repetitive work. But the path to get there apparently involves humans doing repetitive work, so the AI can watch.
The thing I keep asking is, what happens after the training phase? Do those workers transition to something else? Or does the AI just replace them and they're left with nothing?
Right. And nobody's talking about that part. What do you think? Is this just the cost of progress? Or is there a better way to handle this transition? Drop a comment below. I'd genuinely love to hear your thoughts on this one.
It's a tough one. Because you can't stop the technology, but you can decide how the transition happens.
Yeah, exactly. Okay, so let me lighten things up a bit. Quantum computing just solved one of its biggest engineering problems, and nobody's really talking about it yet.
A new network system called XCOM has achieved 100 picosecond synchronization between quantum control boards. That's 100 trillionths of a second.
Okay, in English, please.
Right. Quantum computers need absurdly precise timing. Every qubit has to be controlled in perfect sync. If the timing drifts even slightly, the whole system falls apart. That synchronization constraint has been a major bottleneck in scaling up qubit counts.
So XCOM solves it with a full mesh network. Every control board talks to every other control board directly. No central bottleneck, no single point of failure.
The result? You can build bigger quantum systems, more qubits, more complex computations.
This is the kind of breakthrough that doesn't make headlines because it's infrastructure. But infrastructure is what lets the flashy stuff happen later.
The boring bits.
Yeah, the boring bits are where the real progress happens. And the timing is interesting, because we're starting to see quantum computing move from proof-of-concept experiments to actual engineering problems, synchronization, error correction, scaling.
These are solved problems in classical computing. In quantum, they're still being figured out, but they're being figured out, and faster than most people realize.
Right. Okay, so now this is where things get properly interesting. Consumer robotics is moving fast. Humanoid robots, autonomous cleaners, AI companions for elderly care, all shifting from prototype to production, real products shipping to real homes.
But here's the friction.
Right. The US and EU have built completely different regulatory frameworks, and companies trying to ship to both markets, they're now stuck choosing between two incompatible compliance paths.
The EU has clarity. The Machinery Regulation and the AI Act create a defined framework, clear categories, clear obligations. If your robot counts as a high-risk AI system, it gets third-party assessment. You know where the line is before you cross it.
The US? No single framework. Instead, you've got the FTC enforcing consumer protection laws case by case, individual states passing their own AI acts, Colorado, Texas, California, all different, and the CPSC just sort of waiting to see what happens.
So if you're a robot maker, you're designing for two regulatory worlds at once, one that tells you exactly what to do, and one that tells you to figure it out yourself, then enforces after the fact if you get it wrong.
Yeah, and that gap, that's where the risk sits. Luma, have you seen how this is playing out for companies actually trying to ship?
Well, the recent executive order signals the federal government wants market-driven innovation over prescriptive rules, which sounds good, right? More flexibility. But here's the trade-off: less certainty. And if you're a company building robots, uncertainty is expensive.
Right, because you can build fast, but you can't ship fast unless you know which rules apply.
And safety standards for consumer robots are still being borrowed from industrial and automotive playbooks, which doesn't map well to in-home use, because the whole point of a consumer robot is that humans and robots share the same space. That's a different risk profile entirely.
Yeah, exactly. And transparency requirements are becoming the enforcement priority now. The FTC is cracking down on AI washing, exaggerated claims about what AI can do. And algorithmic bias? That's now a compliance obligation in Colorado and Texas, not just a best practice, an actual legal requirement.
So speed to market now depends as much on your compliance strategy as your engineering.
Worth thinking about if you're in this space, because the market's moving but the rules haven't caught up. Okay, so completely different topic now, but stay with me, because I think this one's really important.
Azim Ajjar wrote something this week that I keep coming back to. He's been tracking a shift that's quieter than the robot conversation, but maybe more fundamental. We've moved from a training-first world to an inference-first world.
What does that actually mean?
Tokens are no longer an IT line item. They're a productive input, like electricity or office space. You don't think about how much electricity your kettle uses, you just use it. Tokens are heading that way.
And there's a project called OpenClaw. It's GitHub's agentic layer, and it's showing how this plays out in practice. AI agents that continuously run. They check your calendar, scan your emails, grab the news, then wait for your follow-up questions.
So not a one-shot query, a persistent agent that's always there, doing work in the background.
Exactly. One developer turned GitHub Copilot into an AI agent and wired it to Discord, scheduled tasks, check the news, check emails, ask a follow-up question 2 hours later. No complex framework, just practical agent patterns that actually work.
And this is the bit that really matters. AI agents aren't replacing tools, they're replacing workflows. The whole sequence of steps you used to do manually now happens autonomously. That's not automation, that's delegation.
But, and Azim's really clear about this, there's a responsibility gap forming. AI can generate exploratory analysis fast, really fast, but sharing that analysis without verification, that's where things get messy.
Because the output looks polished, It sounds authoritative, but it might be wrong, and most people can't tell the difference.
Yeah. The thing I keep asking myself is, who checks the agent's work? If an agent pulls news, summarizes it, and sends it to your team, who verifies the summary? If nobody does, you've just automated misinformation. Think about that for a second.
This is actually where neurodiversity can be a real strength. People with ADHD or autism often have very different pattern recognition skills. They notice inconsistencies others miss. That kind of perspective is valuable when you're verifying AI outputs.
That's a really good point, and it's Neurodiversity Celebration Week, so worth thinking about how different cognitive styles bring different strengths to this kind of work. Okay, so let me lighten things up again, because this next one is properly clever.
Someone built a health coach?
Yeah, but not the usual throw an LLM at it kind. This one's properly engineered. It's called Vico, and the breakdown is worth your time if you're building anything with wearable data.
Here's what they did. They normalized fragmented data from wearables, heart rate, sleep, steps, all the usual stuff. Then they calculated Pearson correlations to find personal patterns. Not generic advice, your patterns. What affects your recovery? What tanks your sleep? Specific to you.
Then they used GPT for coaching, but the clever bit? Self-calibrating predictions. The system learns what works for you, and it's all GDPR by design. Your data never leaves your infrastructure.
What's the running cost?
15 quid a month, hosted on Supabase, built with Next.js open playbook. Anyone can replicate it.
That's actually really good, because it's not trying to replace doctors, it's just helping people understand their own data.
Yeah, the patterns are already there, the wearable's already collecting it. This just makes it legible. And that's the kind of AI use case that actually helps, not hype, just useful.
We talked about wearables back in January, the quantified self movement. This feels like the next evolution of that. Not just tracking, actually learning.
Right, okay, so one more before we wrap. There's a new message broker called Tansu. It's Kafka compatible, written in Rust, uses 20 megabytes of RAM, starts in 10 milliseconds, and scales to 0 when you're not using it.
Okay, translate that for me.
Right, Kafka is the infrastructure that handles real-time data streaming. It's what companies use when they need to process millions of events per second. Stock trades, sensor data, user activity, that kind of thing. But Kafka is heavy. It needs a cluster. It needs constant resources. It's brilliant for massive scale, but total overkill for smaller projects.
Tansu gives you the same capabilities with almost none of the overhead. You can run it on a laptop, you can scale it to 0 when nobody's using it. And because it's Kafka compatible, you can swap it in without rewriting your code.
So the barrier to using powerful infrastructure just dropped. Again.
Yeah, smaller teams can now build systems that used to require dedicated platform engineers. The cost of experimentation just got cheaper. And when the cost of experimentation drops, the pace of innovation goes up.
This is the good stuff, because it's not dumbing things down, it's just making them accessible.
Right, and browser-based video editing is doing the same thing. Proper video editing, not a toy. Using WebGPU and WebAssembly, complex media tasks that used to require desktop software, now running client-side. No uploads, no API calls, no cloud processing fees, just your browser.
So you don't need Final Cut. You don't need Premiere. You just need a browser that supports WebGPU. And most modern browsers do.
The implications for accessibility are huge. Video editing has always been expensive, not just the software, the hardware too. You needed a beefy machine. Now, a decent laptop and a browser. That's it.
And because it's client-side, your footage never leaves your machine. Privacy-sensitive work, marketing agencies handling client assets, journalists working with sensitive material, they just got their green light.
Yeah, the tools that used to gatekeep creative work are disappearing. Not dumbed down, just accessible. And that changes who gets to make things. So, stepping back from all of that, here's what I keep coming back to.
Amazon is building the entire stack. Phone, network, assistant, infrastructure. Nobody else can do that at this scale.
Blue Origin is betting that the next compute constraint isn't software, it's physics, and they're moving infrastructure into space to solve it.
AI training is happening at scale right now, and it's being done by gig workers recording themselves doing laundry. Robots are shipping to 2 regulatory worlds that can't agree on the rules. AI agents are replacing workflows, not just tools. And the infrastructure that used to require entire teams is now accessible to solo developers.
The big picture today, the infrastructure is being rebuilt from orbit to the edge, and the decisions being made right now by Amazon, by Blue Origin, by open source projects like Tansu. Those decisions are setting the terms for what comes next.
Something to think about this week. Where are you still doing things the old way? Because the new way doesn't feel real yet. That's your Luma Digest. Full links are over at luma.marbl.codes, and everything we mentioned today is in the description below. If you're enjoying this, hit subscribe so you don't miss the next one. And if you're building something in the AI space, or just curious about where all this is heading, we're putting together a waitlist for Atlas AI talent, links in the description. Thanks for listening. Until next time.